Have you ever wondered how bolts and metal studs are permanently attached to steel structures without drilling holes or using nuts and bolts? The answer is arc stud welding, a fast, reliable welding process used in automotive manufacturing, shipbuilding, construction, industrial equipment, and many other industries. In this video, you'll learn what arc stud welding is, how it works, its different types, applications, advantages, disadvantages, and why manufacturers rely on it to create strong, one-sided welds in just fractions of a second. Stay until the end because you'll discover why this welding method has revolutionized fastening technology and how it saves both time and money in large-scale production. Imagine attaching a steel bolt to a thick metal plate without drilling a hole, tightening a nut, or even accessing the backside of the material. Now imagine doing it in less than a second. Sounds impossible? Not for arc stud welding. This powerful welding process is responsible for securing countless components in cars, ships, industrial equipment, bridges, and commercial buildings around the world. From dashboard mounts and exhaust system brackets to ship insulation supports and structural steel connections, arc stud welding quietly performs some of the strongest fastening jobs in modern manufacturing. Yet most people have never heard of it. So how can a metal stud become permanently attached to steel in a split second? What makes the weld so strong? And why do industries prefer it over traditional fastening methods? Let's break it all down. What is arc stud welding? Arc stud welding is a welding process that uses an electric arc to permanently join a metal stud, fastener, or weld pin to a metal workpiece. The process works by generating intense heat through an electric arc between the stud and the base metal. This heat melts both surfaces, creating a molten weld pool. The stud is then pressed into the molten metal, forming a permanent fusion bond. Unlike traditional fastening methods that require drilling holes and installing bolts or rivets, arc stud welding creates a direct connection between the fastener and the metal surface. The result is stronger joints, faster installation, cleaner appearance, and improved structural integrity. One of the most impressive features of arc stud welding is speed. A complete weld can often be completed in approximately 0.06 seconds, making it one of the fastest metal fastening processes available today. Why arc stud welding is so important? Modern manufacturing depends on efficiency. Imagine building a ship, bridge, or automobile that requires thousands of fastening points. If every bolt required drilling, threading, and manual installation, production would slow dramatically. Arc stud welding eliminates those extra steps. Instead of drilling holes, aligning hardware, tightening fasteners, and inspecting mechanical joints, the operator simply places the stud, activates the welding gun, and creates a permanent weld almost instantly. That's why industries worldwide rely on this process. Applications of arc stud welding. One of the biggest reasons arc stud welding remains popular is its versatility. It can be used in dozens of industries and countless applications. Automotive industry. The automotive sector is one of the largest users of arc stud welding. Manufacturers use it to attach heat shields, dashboard components, instrument panels, power steering brackets, exhaust system supports, brake line mounts, wire routing clips, lighting system brackets, interior trim fasteners. Because the weld is made from one side, assembly becomes much faster and more efficient. Shipbuilding industry. Shipbuilders use arc stud welding extensively throughout vessel construction. Applications include insulation supports, wire management systems, hatch covers, equipment mounting points, structural attachments. The strength and reliability of arc stud welding make it ideal for harsh marine environments. Construction industry. Construction projects depend heavily on stud welding for structural steel assemblies, building frameworks, metal decking systems, utility supports, equipment mounting. Its speed helps reduce labor costs while maintaining strong connections. Farm equipment manufacturing. Agricultural machinery contains numerous welded studs. Arc stud welding is used to assemble equipment brackets, protective shrouds, hose management systems, wire supports, vehicle cabs, fenders. These components must withstand vibration, impact, and harsh working conditions.
Furniture manufacturing. Metal furniture manufacturers use arc stud welding to create shelving units, storage racks, office furniture, outdoor furniture, and household metal products. The process creates clean, attractive fasteners without visible hardware. Commercial appliances. Many commercial appliances depend on stud welding. Examples include industrial dishwashers, cooking equipment, bottle washers, heating units, and ventilation systems. The process allows components to be securely mounted while maintaining a professional appearance. Types of arc stud welding. Although all arc stud welding methods operate on the same basic principle, there are several variations designed for different applications. Let's look at the most common types. 1. Draw arc stud welding. Draw arc stud welding is the most widely used form of arc stud welding. In this process, the stud contains a small amount of flux on its end. The flux performs several important functions: cleans the weld area, reduces contamination, improves weld quality, enhances weld strength. During welding, the flux vaporizes under intense heat and helps protect the molten metal from atmospheric contamination. This method is commonly used for large diameter studs, structural steel, and heavy industrial applications. 2. Short arc stud welding. Short arc stud welding is similar to draw arc welding, but operates much faster. Unlike draw arc welding, no flux is required, no ceramic ferrule is needed, and welding time is extremely short. Because of the rapid welding cycle, it is ideal for high-volume production, automated manufacturing, and fast assembly operations. However, because speed is prioritized, weld strength may not match that of draw arc welding. Manufacturers often choose this method when productivity and cost reduction are more important than maximum strength. Gas arc stud welding. Gas arc stud welding uses shielding gas instead of flux or ceramic ferrules. Here's how it works. The stud is positioned on the workpiece. Shielding gas begins flowing. The stud lifts slightly. An electric arc forms. The stud and base metal melt. The stud is plunged into the molten pool. Shielding gas continues flowing until cooling occurs. This process is particularly useful for automated production systems because it is cleaner and easier to control. Equipment used in arc stud welding. Several key components work together to make arc stud welding possible. DC power supply. The power source generates the electrical energy needed to create the weld arc. Most systems use direct current because it provides stable arc performance, better penetration, and consistent weld quality. Although both single-phase and three-phase systems can be used, three-phase power is preferred in industrial applications. Welding gun. The welding gun holds and positions the stud. Its functions include lifting the stud, creating the arc gap, pressing the stud into the weld pool. The gun automatically controls timing and movement for precise welds. Ceramic ferrule. In draw arc welding, a ceramic ferrule surrounds the weld area. Its purpose is to retain molten metal, concentrate heat, improve weld strength, and reduce spatter. The ferrule is removed after welding. Ground connection. The ground cable completes the electrical circuit. Without proper grounding, the arc cannot be established effectively.
Why arc stud welding continues to grow. As industries demand faster production and stronger connections, arc stud welding continues to gain popularity. Manufacturers appreciate its ability to increase productivity, improve quality, reduce assembly time, and lower labor costs. Whether it's securing components inside a vehicle, attaching insulation inside a ship, or creating fastening points on structural steel, arc stud welding remains one of the most efficient fastening technologies available. Conclusion: arc stud welding is one of the fastest and most reliable methods for attaching metal fasteners to metal surfaces. By using an electric arc to melt both the stud and the workpiece, it creates strong, permanent fusion bonds in a matter of milliseconds. Its applications span automotive manufacturing, construction, shipbuilding, agriculture, industrial equipment, furniture production, and countless other industries. While it requires specialized equipment and training, the benefits of speed, strength, efficiency, and clean welds make arc stud welding an essential process in modern manufacturing. The next time you see a bridge, a ship, a steel structure, or even your car's dashboard, remember that arc stud welding may be working behind the scenes, holding everything together.